So this is going to be the first video for Notes 62. Note 62 gets into percent problems with an increase or a decrease. And there's a little formula up at the top, old plus or minus percent times old equals new. That's going to be very important for us to use when we're solving these problems. Now, I did mark these all with a asterisk, which means all of these are calculator problems. So I do have a calculator handy and ready to go. But let's set up the problem first before I get to need the calculator part. All right, so it says a worker's salary increased. That's going to be the first keyword here. Increased 45%. If he made $300 per week, how much would he make after the increase? So I know the old, I know the percent, I know the increase is going to be plus, because when we look at this problem, it says plus or minus, and what we're trying to figure out is the new, okay? So old is $300, so 300 plus the percent is 45%, but 45% is 0.45 as a decimal. Reminder, 45, whoops, write the percent sign. If you divide that by 100, that will turn it into the decimal that we're looking for. All right, so 45% times old equals new. I'm just going to put N for new. So this is what we're trying to figure out, and that's what's going to go in the calculator. So 300 plus 0.45 times 300. And so the new is going to be 435. That's a heck of an increase. All right, so that's what, after a 45% increase, person went from making $300 per week to $435 per week. All right, so Brad here has had a weight increase. All right, so I'm going to go through and start just highlighting things. So increase 8%. All right, if his weight is now 216 pounds, what was his weight before the increase? So let's see what we know. We know that the increase is going to be add. 8% is what we have for percentage. And then this is the new. We're looking for the old for Brad here. Okay, so if we set this up, all right, so remember it's, and I'm going to replace this in a second. So it's old plus or minus percent times old equals new. Okay, so old, I don't know what that is. I'm going to go ahead and use X here because I don't want to use O, because O's to me look like zeros and then I get really confused. Increased, so plus, percent is going to be 0.08. Again, 8% divided by 100 is 0.08. Please, for the love of all that is good, do not think that it's 0.8. It's an 80% increase, and 8% versus 80% is a huge difference. All right, so that's going to be an X here because I still don't know what the old is, but the new weight was 216, so 216. And this is what I want to now solve. Now, I have an X here plus 0.08X. So this X has a lovely 1 in front of it that we kind of ignore, but it is there. So when we go to add these two terms, because they are like, this becomes 1.08x equals 216. So to solve for x, let's go ahead and divide that by 1.08. So x equals, let me grab my calculator, slide that on over, clear. All right, so 216, not times, divided by 1.08. Let's put the decimal in the right place. All right, so 200 and LBS if you want to put pounds in there. All right, so before his little weight increase, Brad used to weigh 200 pounds. All right, so that's number 2 here. Number 3. All right, so this time we're looking at a decrease by 23%, but its sale price was still $15,400. What was the original price? So when we look at, all right, what do we know? Well, decrease means we're going to be subtracting. 23%, clearly that's the percent. The sale price is the new price. right? When you have an old price and you apply some kind of a discount to it, that becomes the sale price. So let's see what we got here. So old plus minus percent times old equals new. Okay, the old price. I don't know. Again, I'm going to call it X. But this time we have a decrease. So we're going to have a subtraction problem. 23% is 0.23x. So 0.23%. Or 0.23 is the decimal equivalent of 23%. Old is X because I don't know what it is. Sale price, 15,400. All right, and if you need the reminder, 23% divided by 100, that will turn it into the decimal equivalent. Okay, so if we're looking to do these and add them up, again, the X is going to have a 1 in front of it. So I'm going to take 1 minus 0.23. So 1 minus 0.23, so that's going to be 0.77. So 0.77x is equal to 1,400. Make that go away for right now. And then to completely solve for x, we're going to divide both sides by 0.77. All right. Absolutely none of that is happening in my head. So 15,400 divided by 0.77. The original price of the car was an even $20,000. If that was the price of a brand new car, it'd be kind of nice. Not too bad. Okay, problem number 4. Okay, we have Jenny here. Jenny's scores increased from 80 to 92. What was the percent of increase? All right, so what we have is the old score. We have the new score, and the percent is what we don't know. Okay. So if we look at our formula, old plus or minus percent times old equals new. So the old score is 80. We have an increase in percent, and we also know that the score went from 80 to 90. So that's how we know, again, we have an increase. So that's going to be a plus. Percent. I don't know what that is, so I'm going to call it P for percent. The old score is 80. I'm going to use parentheses here to mean multiplication. And then the new score is 92. And my job is to solve for P. So first thing I want to do is I want to subtract 80 from both sides. So P times, I'll use the parentheses still. P times 80 is equal to 92 minus 80 would be 12. I write huge. Divide both sides by 80. All right, and we're going to get P is equal to, so let's see what 12 divided by 80 is. All right, so 0.15. Now we have a small problem. And the small problem is this is the decimal equivalent, but it is not the actual percent. So in the last 3 problems, right, in each of these last 3 problems, we had a percent that we changed to a decimal. Percent, change it to a decimal, percent, change it to a decimal. Well, now I have a decimal that I need to change to a percent. So we're going to do the exact opposite, which is to take our decimal equivalent, and we're going to multiply it times 100. So if you need to do that on a calculator, times 100, it is 15%. All right. So Jenny's scores increased. The percent of increase was 15%. All right. Number 5 is kind of hiding off to the side here. What percent of 300 is 360? So this is percent times total equals part. Okay. So percent total equals part. So what percent of, I don't know the percent, so I'll go ahead and use percent, of 300 is, 360. Okay. So I'm going to go ahead and divide both sides by 300. So 360, what the heck? Scientific, go ahead. So 360, what was that, divided by 300? Trying to see if the calculator, there the calculator will move. Yeah, 300, okay, yeah. Okay, equals 1.2. So that's the decimal equivalent. So 1.2, and then if I multiply by 100, it's 120%. All right, what percent? Yep, that makes sense. All right, and the last question for this particular video is going to be number 6 here. Dear Lord, I wish I owned some Apple stock. The price of Apple stock soared from $17 a share to $98 a share. What was the percent increase? It's the exact same thing as number 4 here. We know the old, we know the new. It's the percent that we're looking for. All right, so let's see what we got here. Old plus or minus percent times old equals new. The old cost, 17. We definitely have an increase. Percent, I don't know what it is. I'll go use P for percent. The old is 17, and then the new is 98. Yep, I set that one up right. I'm making sure I did my math right. All right, so we got to solve this thing for P. I'm going to subtract 17 from both sides. So P times 17 is equal to, let's see what we got here, 98 minus 17, I think is 81. It is. And then I'm going to go ahead and divide both sides by 17. Divided by 17, that's probably, yeah, that's not going to be very pretty for a decimal. So P is equal to 4.76. Yeah, that's good enough. And then if I, actually, let me go ahead and put one more. 0.76, I don't know, 47. There we go. So let me go ahead and then multiply that times 100. So that way we get the 470. Yeah, you can have a decimal equivalent. Whoops. Apparently I can't write though. Okay, calculator, go away. There we go. And then, okay, so 0.47%. So what I was getting at before my calculator decided to overtake my screen, you can have percentages of increase that are well greater than 100%. All right, and clearly we've seen that with this particular problem. And you even saw that with the last one where you had 120%. All right, this is where I'm going to go ahead and close this video up. I will have a separate video for problem number 7, getting back into distance and midpoint. As always, if you have any questions or concerns, please do let me know, and I'll see you in the next one.